Okay, so this is the classwork for lesson 14.2. And the first part of the classwork asks us to determine if the ratios form a proportion. So remember, if two ratios are proportional, that just means that those ratios are equal, and we can put an equal sign in between them. There are three different ways to determine if those ratios are equal. It's like comparing fractions. So you can reduce those ratios to simplest form, you can find a common denominator, you can cross multiply. We're just looking for them to be equal. And it doesn't matter which of these strategies you use. You can pick one and just stick to it, or you can look at the problems you're working with and figure out which strategy works best for that problem. So for our number 11, 7 halves and 16 to 6. So for this question, I'm going to just reduce to simplest form because 7 to 2 is already reduced. So 7 over 2 is already in simplest form. 16 and 6 can both be divided by 2, and we get the ratio 8 to 3. These are not equal ratios. So for a number 11, we would say no. Okay? Number 13. Tell whether X and Y are proportional. And then it gives us this table with 4 different ratios to compare. So let me set it up. Okay, so we have 1 to 7. We have 2 to 8. We have 3 to 9 and 4 to 10, okay? And think of this as your ratio, X to Y. And then here are the 4 ratios that we have to compare to determine if it's proportional. In other words, if it's equal. All 4 of these ratios have to be equal in order for us to say that X and Y are proportional. So I'm going to simply reduce. I can tell by looking at them, and I bet a lot of you can too. But if we want to have mathematical proof, we will show all of these ratios reduced to simplest form. These can be divided by 2 for a 1 to 4 ratio. These can be divided by 3 for a 1 to 3 ratio. And these can be divided by 2 for a 2 to 5 ratio. So none of these ratios are equal. So definitely a no. They would all have to be equal. Okay? Number 15, tell whether the 2 rates are proportional. Remember, rates are just ratios that have different units. So we will just take those words given and we'll write them as fractions right away. So for number 15, it tells us 7 inches in 9 hours. So I'm going to write that as 7 to 9. And then the second rate given was 42 inches in 54 hours. So then we're going to use the strategies that we did up here. One of these, we have to pick one of these to determine if those ratios are equal, if they form a proportion. So let's start by dividing these. You can divide by 2 at first, you can divide by 3. How about we start by dividing by 6? Okay. 42 divided by 6 is 7. 54 divided by 6 is 9. This is in simplest form. 7 to 9 is already in simplest form. These are equal, so we would say yes, those 2 rates form a proportion. Number 17. 440 calories in 4 servings. And the second rate is 300 calories in 3 servings. So again, you can pick and choose your strategy. It doesn't matter. I'm going to just reduce these to see what happens. So these I'm going to divide by 3 to get a 100 to 3 ratio. You may be able to tell just by looking that this probably will not reduce to 100 to 3. So we can say no right away. If you wanted to prove it, you could divide by 4, divide by 4. 4 divided by 4 is 1, and 1/10 on top. So these are not equal. So we would say no, those do not form a proportion. Okay? Number 19. Same idea, 66 wins in 82 games is the first rate. 99 wins in 123 games. And you can choose your strategy how you want to prove that these are equal or not. So maybe we want to start by dividing by 2 here, just because maybe we don't know what works. So 66 divided by 2 is 33. 82 divided by 2 is 41. And I don't see anything else we can divide by. So let's see what we can divide by here. So I know 99 is divisible by 3. If I look at my denominator, these digits add up to 6, so I know that's also divisible by 3. Let's see what that works out to. 99 divided by 3 is 33. And then if I want to work this out, 123 divided by 3. 3 goes into 12 4 times, into 3 once. So 33 to 41. These are equal. So yes, they are forming a proportion. 21. And you can do 90 sit-ups in 2 minutes. Your friend can do 135 sit-ups in 3 minutes. Do these rates form a proportion? So we need to prove if these are equal or not. Like, we can't compare because they have different denominators. So I'm just going to reduce them to see if they're equal. So half of 90 is 45. Half of 2 divided by 2 is 1. So 45 to 1, or 45 sit-ups in 1 minute. So I know these are divisible by 3. These digits here, 5 plus 3 plus 1, add up to 9. So I know I can divide by 3. So 3 divided by 3 is 1. 135 divided by 3 goes in 3 times at 9. Subtract, I get, oops, Miss Marion made a mistake, 4. 4 times 3 is 12. That's so much better. 13 minus 12 is 1. Drop down the 5. 3 goes into 15 5 times. Sorry about that. That is what Mrs. Marion calls a whoopsie. These are equal. So yes, they do form a proportion. You can both do 45 sit-ups per, oops, I drew a not equal sign. I'm not with it right now. Whoops. Yes, equal. Another whoopsie, 2-in-1 problem. But you get the idea. These are equal, so they do form a proportion. Yes, you can do 45 sit-ups per minute. 23. Tell whether the ratios form a proportion. So then it gets a little tricky because they throw in some decimals. And I think the easiest way to tackle this problem, I've reduced a lot in this classwork. I haven't used the other strategies, but I'm going to now. I'm going to try cross products to see if my cross products are equal, and that will tell me if the ratios form a proportion. So 4 times 7 is 28, and then I have to work out 11.2 times 2.5. 5 times 2 is 10, carry the 1. 5 times 1 is 5, plus 1 is 6, and 5 times 1 is 5. Done with the 5, placeholder. 2 times 2 is 4, 2 times 1 is 2, 2 times 1 is 2. Add them up, 0, 6 and 4 is 10, carry the 1. 5 plus 2 plus 1 is 8, 2 plus nothing is 2. Well, I can estimate where the decimal point goes. 11 times 2 is 22, 11 times 3 is 33, so it makes sense for my decimal point to go right here. You could use your strategy, 2 numbers behind a decimal point, and hop it twice, and you'll get the same. So look, the cross products are equal, so we would say, yes, these form a proportion. Okay, so maybe you don't want to get in the habit of always sticking to that one strategy. Okay, last one, and it's a doozy because they give us what are called complex fractions or fractions inside of fractions. So the first one, the first ratio, look at where that colon is. It's 2 to 4/5. That's the first ratio. Then it separates by a comma, so that's telling us our next ratio is starting. The next ratio is 3/4 to 10. Okay, we have to determine if these two ratios are equal. We need to get rid of the fractions, okay? So we have to multiply the numerator and the denominator of any fraction by the same number so that we get an equivalent fraction. So you have to look at your denominator. In the first ratio, the denominator is 5. So if I multiply by 5/5, okay, I'm going to get an equivalent fraction here, right? I multiplied the numerator and the denominator by the same thing. Let's do the numerator first because that's straightforward. 2 times 5 is 10, so that's our numerator. Then let's tackle our denominator. Now we're going to multiply 4/5 times 5, or 5/1. These 5s reduce to 1s, and 4/1 times 1/1 is just 4. Okay, so I've worked to eliminate the fraction inside the fraction. Okay, then my 4/10 can be reduced. I can divide these by 2, and my final fraction is 5/2. So then let's look at your second ratio. You have to multiply the numerator and the denominator by the same thing. You don't want to choose 5, that's not going to be helpful. Look at your denominator. The denominator is 4. So we have to multiply a fraction's numerator and denominator by the same thing to keep it equivalent. Okay, we have to keep this ratio equivalent. So let's do the denominator first in this case. 10 times 4 is 40. Okay, and then let's do the numerator. 3/4 times 4. You can do it, work it out the long way if you want. Reduce those 4s to 1s. 3 times 1 is 3. 1 times 1 is 1. So 3/40. Well, 3/40 is already reduced. Oh, oopsies. I had a whoopsies. Another, I'm full of them today. It must be a long day. Whoopsie. The denominator here, it's not going to be that big of a deal. Okay, the denominator here was not 10. The denominator was 3/10. Okay, we got to do this part over. Sorry. So I'm going to transfer this over to my next page, 5/2. I copied that problem wrong. Okay, so the second ratio was 3/4 to 3/10. tenths. That was our complex fraction. Now we have to multiply by the LCM of our denominators to get rid of those fractions within the fractions. So the LCM here would be 40. So times by 40 over 1 times by 40 over 1. Okay, so 4 goes into 4 once, 4 goes into 40 10 times. 3 times 10 is 30. Okay, so this is what I worked out. 10 goes into 10 once. 10 goes into 40 4 times. 3 times 4 is 12. Now we can reduce 30 and 12 by 6. 30 divided by 6 is 5. 12 divided by 6 is 2. So our final fraction here is 5 to 2. If we compare it to that first ratio that we already worked on, that was 5 to 2, which makes those, equal. Okay, I think I should stop for today. All right, I hope that helps. Sorry about all the whoopsies, but we all make mistakes and we do the best that we can. Okay, here's a couple of smiley faces. There we go. Bye.